Hey all, a quick little lesson here about simplifying radicals. This is something you're going to need to know how to do for the next couple of lessons, units that we're going to do. So I want to make sure you're really solid on the process for simplifying radicals so that you can do that every single time. So our goal is to be able to simplify a radical that does not have an integer square root. So this is one of those where if you put it into your calculator, you would get a nice long decimal. We are going to talk about how to simplify those so that they can stay exact. So I have a couple of easy steps for you. When you are simplifying a radical, first make a factor tree. Look for pairs in the roots and the factors, and then any leftovers stay inside the radical. So let's start with 12. We're going to make a factor tree for 12. I know that 12 is 4 times 3, and I know that 4 is 2 times 2. Remember back to, I don't know, 4th or 5th grade, when you were making factor trees and you break down every number as much as possible. Now, when we're looking at our factor tree, we're only considering the roots. We don't care about the branches. So I don't care about the 4. All I care about is the 2, and the 3. I want to know, do I have any pairs? I do. I have a pair of 2s. What happens to that pair is that it comes outside the radical, and then any leftovers that don't have a pair, in this case the 3, stay inside. So the square root of 12 simplifies to be 2 times the square root of 3. Okay, so any pairs come outside as 1, any leftovers stay inside the radical. Let's try another one with 98 here. Let's make a factor. This one's kind of hard, but I know it's even, so I'm going to divide it by 2. And I know that 2 times 49 is 98. 49 I know is 7 times 7. Once again, I'm looking for a pair to come outside. That's the 7. And then the leftover stays inside, which in this case is the 2. So again, I'm making a factor tree, looking for pairs. Let's try a couple more. So 72, I'm going to make a factor tree. I know that's 8 times 9. 8 is 4 times 2, and 4 is 2 times 2. 9 is 3 times 3. This time I have a couple of pairs. So I have a 3 and a 2. I'm going to multiply those to get a 6 outside the radical. So anytime you have more than one pair, multiply those numbers together. I mean, it could be 2 times 3 times 5 or whatever you have pairs of. Multiply them together. That's what comes outside. Again, any leftovers, in this case 2, stay inside. If you have more than one leftover, you multiply those as well. Okay, so let's do 108. That's 9 times 12. 9 is 3 times 3. 12 is 4 times 3. And 4 is 2 times 2. So again, I have a pair of 2s and a pair of 3s, which I multiply to get 6 outside the radical. This time, my only leftover is a 3. So I have 6 square root of 3. Both of these radicals have now been simplified. That's going to help us later on when we're trying to reduce things. So make sure that you are simplifying radicals every time. We'll do a couple more just to make sure that you really feel solid on this. Okay, so 54 is 6 times 9. 6 is 3 times 2, and 9 is 3 times 3. Here I have a pair of 3s. Those are going to come outside. And now I have 2 leftovers. I have a 3 and a 2, which I'm going to multiply, which gives me 6 inside the radical. Okay, so did everybody follow that? When you have more than one leftover, you simply multiply them, and that's what goes inside the radical. So if I had a 5 and a 2, I'd have 10 in the radical. If I had 3 and 7, I'd have 21 in the radical. You're multiplying whatever your leftovers are and keep them inside the radical. Okay? 80 is, let's see, 4 times 20. 4 is 2 times 2. 20 is 5 times 4. And 4 again is 2 times 2. By the way, it doesn't matter how you make your factor tree. Your branches might be different, but your roots will always be the same. So if you're doing it and your friend is doing it, maybe your branches are a little different from each other, but you just still get the same numbers at the bottom. Okay? Now this time I have a pair of 2s and another pair of 2s. I'm going to multiply those to get 4 outside the radical, and then my leftover is a 5. Okay? So I hope that this has made sense for you, simplifying radicals, making factor trees, looking for pairs. This has been another production of Con Alonso Inc. We are always here to help you. If you have any questions, please be sure to let us know. Take care.